Hello, welcome to AT&T ThreatTraq for January 6, 2015. This program provides network security highlights, discussion, and countermeasures for cyber threats. First off, Happy New Year to everybody. Joining me on the couch today is Matt Kaiser. Hey Matt, how you doing and how was your time off?
Doing pretty well. Yeah, I had a nice relaxing time. Spent a little time watching videos from Chaos Communication Congress, which is a hacker convention out in Hamburg, Germany. So
right.
A lot of really good talks.
There's some interesting talks there. I didn't get to watch it myself, the live streams, but I know that there's some of them available on YouTube and whatnot. You can watch them. Also joining us via remote is Jim Clausing. Hey Jim, how's it going and how was your time off?
Yeah, not too bad. Had a really nice vacation. It's nice to get some time off and spend some time with the family.
All right, sounds good. And I don't think we had any major announcements or crises over the holidays, which is a good thing. No heartbleed type level things or what was the other one, shell shock and things of that nature. So I'm sure there'll be things happening. January is usually a very busy month for cybersecurity, it seems like. For some reason, there's always new things emerge, it seems like, in January. I won't speculate as to why that is. But in any event, I'm John Hogoboom, by the way. I'm filling in for Brian Rexroad this week. Brian's off speaking at the International Conference on Cybersecurity, the ICCS. If you're interested in that conference, I don't think they have live streams, but you can check their Twitter feed. It's at ICCSNY, and that'll get you some information about that conference. Interesting conference and a lot of interesting topics and people notably in the cybersecurity realm speaking there. So it's a good program to check out. So first story on our docket here today is Spamhaus released a botnet summary for 2014. And I think you were going to cover that one, Matt, and you have some info on that one?
Sure. This is a really good collection of statistics from Spamhaus. They keep an eye on command and control for different botnets. Some really interesting little tidbits in here that I wanted to share. They say, 50%, or at least a little bit more than that, a majority of command and control seems to be compromised web servers, which is a little bit less control for the botnet owners, but it also means that they don't have to pay for the infrastructure and catch the heat if they can distance themselves from owning it. They talk a little bit in here about the different hosting providers. They say that there's three major factors in choosing a hosting provider. One is choosing a hosting provider that has some sort of automated sign-up that has very little validation of who the new owners actually are, which allows cyber criminals to create large numbers of command and control without being shut down or detected. The second is finding a provider that also doesn't have much in the way of an abuse department, because as we know, an abuse department's job is to prevent this sort of thing from happening. It's against most terms of service. We have your bulletproof hosting, but you also have legitimate smaller companies on this list of the top ISPs or hosting providers that are being abused. The smaller ones tend to have less resources and less of ability to fight back against this. And the third factor that is apparent from this data is finding jurisdictions in which to be hosted that have either very lax cybercrime laws, or they have no extradition treaties or no strong legal ties to the countries in which the victims usually reside.
Right. Yeah, I know that for years we've observed some patterns with certain botnet operators who were smart enough to place their command and controls in countries that don't have very good relations with where most of the victims are. So, maybe most of the victims are in the United States, and they put the command and control in some country that the U.S. doesn't have very good communication with. There could also be language barrier issues just in general when you're trying to communicate with the ISP that is hosting that command and control about what needs to be done and what you're trying to communicate, that there's command and control there. The other thing I thought was interesting somewhat about this article is the number of command and controls. Zeus, Citadel, which is an offshoot of Zeus, are in the top spot by a large margin. And I think Game Over Zeus was still in there too, and there was a big takedown operation with that one as well, which might account for why it's less, but it was also kind of a spin-off segment. The one thing I don't know if they had in this article that I was kind of curious about was actual infection rates. So just because you have certain families of malware that have a lot of command and controls. That makes it harder to deal with those families in general, take down those botnets. But if there's even a botnet that has just a few controllers, could have a lot of victims that are participating in it. It'd be nice to kind of know the relative sizes of populations of these different families. But I don't know if they even had those statistics. They probably didn't for the study they were doing.
Right. This seems to focus purely on the command and control structures, domains and IPs associated with that. You're right. That would be fascinating information to have, though.
Right.
One more interesting point, which is probably no surprise to some people in the cybercrime, anti-cybercrime community, is that the top-level domains that are most frequently abused, besides .com and .net, are .ru, Russia,
right,
and .su, Soviet Union,
right,
which is kind of an oddity that one's still around, even though there's no longer a Soviet Union, but it seems very popular and rife with abuse.
Right. Yeah, I've noticed that as well, and as a lot of people know, a lot of crimeware is kind of Russian Eastern Bloc type operations engaged in that activity. Also, not surprising when you look at this list, the families of malware here in the notes section, you'll notice almost the majority of them are e-banking Trojans, which basically translates to crimeware. They're trying to steal your credentials so that they can get into your bank account, or other types of financial type fraud activity. So interesting article. I don't know if you had any other insights into it, but it looks like things aren't going away. It's definitely a steady amount of command and controls here, and they really didn't decrease as far as I can tell.
They actually did increase roughly about 8% over last year.
8%?
That's what they said.
Okay. Yeah, it wasn't super, it's kind of hard to see from the chart here, but in any event, good article, and I think it's a good thing for people to check out just to get a relative feel for the kinds of activity that went on last year. And speaking of that, we're going to transition to Jim's story about Poweliks, which was not on this list. However, I have noticed that Poweliks is a new family that I'm not really super familiar with, so hopefully Jim can fill us in. But it seems like it's kind of taken root over the past month here or so. I'm seeing a lot more infections of this particular family. So you want to give us the skinny on that one, Jim?
Yeah, it's the Poweliks has actually been around for at least half a year. The first write-ups that I remember seeing about it were like August or something of last year. I think Trend Micro had a couple of write-ups about it. Poweliks is a new family of malware that hides in the Windows registry, so there's nothing to find. There's no separate executable on the disk anyplace to find. And I think we've mentioned these types of malware in the past, but what this one does is it uses what was new to me anyway, a relatively unique auto start mechanism. It hides its code in one registry key and then uses CLSID key to actually execute it. It runs JavaScript, and the malware is JavaScript that's hidden in the registry key. So it's kind of an interesting new trend that we're seeing with the malware. And as I said, it's been in the press on and off for a few months, but I hadn't really paid a whole lot of attention to it. I've noticed on some of the lists I'm on, people have started talking about it more in the last month or so. And as you said, we're seeing evidence of infections appear to be ramping up, at least in what we've got visibility to in the last month or so. So Corey Harrell had a nice article on his blog, The Journey into Incident Response, which is one that I read regularly, and I highly recommend it, actually, if you folks are interested in incident response and digital forensics. He's a good guy to follow. And he did a blog post this past weekend, um, trying to see what artifacts he could find, what evidence he could find, um, how he could tell if systems in his enterprise were infected. And so it's a really good article. It goes through. You'll see he goes through the prefetch files that he finds, and doing some memory analysis to figure out. Basically, this one uses a DLL host and injects the malicious code into an instance of DLL host. So if you're looking at the processes running on your Windows system, what you'll see is DLL host, and this one will be doing a lot of outbound network connections. The key indicator that he found that was most useful for discovering if you've got systems that are infected was in the registry with the run DLL 32 executing JavaScript and the run HTML application. So that's a string that you can look for in your registry to potentially find infected machines. But it's an interesting new family. As I said, I haven't really spent a whole lot of time looking into it, but now that we're seeing more evidence of infections, it's one that I will probably spend some time this week looking at.
Do you have any, I didn't get a chance to read the article, but did they mention what the intent of this family of malware is after? Is it crimeware, or is it, Bitcoin mining, or some other type of thing going on with it?
The couple that I've looked at are mostly looking for how you can tell if you're infected, and they tell me there is network traffic, but I don't actually remember any of them saying what it was that they were after.
Okay, well, it definitely bears some more investigation because, like I said, and I think we've all kind of observed, I think there might have been, and I haven't gotten to the root cause of this, but there might have been some kind of spam run that went through and swept up a bunch of victims around the middle of December, right before the holidays. And I've noticed an increase in Poweliks infections. I don't know if that's just, what I'm saying is what actually happened, or if it's just that we have better detections than we had before. It's hard to say. But definitely seeing Poweliks showing up on the radar a lot more in the past month. So definitely one to keep an eye on. And I would imagine other people out there watching the program are struggling in their enterprises, looking into trying to figure out how to get rid of this type of malware off of those machines.
Right, because what I do see, what I have seen in the articles that I've looked at is, when they check in with the command and control, the normal, this is the OS and the malware version, the build date, that kind of stuff. But I haven't seen exactly what it is that they then do once once the controller has control of all of these infected machines. So,
All right.
and cleaning it up can be a trick because sometimes they're using what Trend called a null registry value to hide it, and the null registries are hard to delete.
Yeah, I think they're hard to find too, if I remember right. Like if you look at them in
It can be
regedit.
hard to find, especially on the system. The malware actually protects itself against folks on the system finding it. One of the articles that I was looking at actually suggested the best way to find it is to connect remotely with something like Encase or one of those forensic tools, because they hide themselves from the users on the local system.
Mm-hmm. All right, interesting one, and hopefully we'll find out some more information about how it works in a little more detail and what the intent is behind it. hopefully it doesn't become a bigger problem than it already is. But a good article. I did take a quick look at it. The article you mentioned here by Corey Harrell, very detailed, in depth. So I'd recommend people check it out. If you're interested
the
in
other
that.
one that I recommend is the November write up from Trend Micro on the auto start mechanism and how it works.
Okay.
That's also a good one, and it talks about how to go about removing it. But yeah, this is certainly one that we'll be keeping our eyes on for the next few weeks, and we'll probably, once we have a better understanding of it, we may come back and talk about it on the program again.
Okay, great. Thanks for that. And now, shifting back to Matt, this one's a little bit off the beaten path, but an interesting article, something people probably want to be aware of. An expensive mistake that somebody made when using Amazon's cloud computing service.
Yep. So this one is for my developer friends out there. You know who you are. This is a story on DevFactor, the website, and it's a little anecdote on why you shouldn't be too hasty in committing things to GitHub.
Right.
For those who aren't familiar with it, GitHub is a source control system, uses the Git source control application, which is very popular these days. The story is basically an anecdote about someone who's starting to learn how to use Ruby on Rails for web app development, needs a place to store some images for the application that they're putting together, and decides to use Amazon's AWS service. In particular, they wanted to use S3, which is the storage portion. So basically you upload to the cloud and it gets hosted there, a little bit more flexible. When you use Amazon's AWS, you have to have an API key, and when they were committing their source code to GitHub, they apparently accidentally committed the key as well. They thought they had taken precautions to prevent the key from being put into there. There's little things you can configure in Git. The Git ignore apparently didn't take, and boop, their key was up on GitHub, which basically means it's world readable.
Right, yeah.
Anybody can take a look at it. It was there for about 5 minutes. The person who put it up there thought that they had taken it down, and then realized that the next day that someone had written a bot that was scraping GitHub looking for AWS keys. Now with the
Because
key,
apparently more than it's not the only problem. He's not the only one who's made this mistake. Other
Yeah.
people as well.
Someone has
People have
decided that
engineered
it's-
bots to go look on GitHub. For
precisely,
these
and
types
what
of
they'll
keys.
do with it is they'll take that key and use it to spin up Elastic Compute Cloud instances, EC2 instances, which is basically like creating your own computers up in the cloud,
Yep.
specifically for Bitcoin mining.
Oh,
So
okay.
his key was all up there for all of 5 minutes, and it was swept up by the bot, and he got a bill of over $2,000 for that tiny little mistake. So the moral of the story is be very, very careful what it is you post up on your code sharing sites, because this sort of stuff does happen, and it can really be costly. Luckily, Amazon, he explained the situation to them. They revoked the charges. It's, he's okay now, but keep an eye on these sorts of things. If you happen to be a developer, you happen to be using these cloud services, or basically, I could even say just be careful what it is that you share on these code sharing services. I've heard of people accidentally sharing SSH private keys or
Right.
other configuration for the system that they want to have a backup in the cloud for. I mean, it's somebody out there will realize the value of the data that you're storing and automate a way of stealing it from you and profiting from it.
Yeah, absolutely. Yeah, I used to be a developer. I worked with a lot of developers, and I know some of them probably would have said, well, who's going to be even interested in my code and want to go look through it? And, who cares that I put a key up there? But I think that's obviously that's a naive thing, that people don't realize that there are bad actors out there with a lot of intent to scrape or review these types of data sets out there, especially there's other source code control systems out there too, besides just GitHub, and look for this type of data that they can use for their own purposes, and you might not even thought like how they could leverage that in their own things, like they did here to spin up Bitcoin mining instances. Also, I just want to mention that this particular problem is a user issue. It's the user, the developer, was the one who made the mistake.
Right.
It's not a fault of
GitHub's
Amazon.
fault. Right.
Amazon didn't make there's no fault on them, no fault on GitHub. It's the fact that the user wasn't careful about where they stored their keys, and you got to be careful, like you said.
Yeah, and if he's just keeping it on his local system, he can fix that. But if you put it out there on a cloud service that's open to the public, like you said, these bad guys have bots running that are constantly scraping these sites, and so it doesn't take long. You put it out there, even if you manage to pull it right back, chances are somebody's going to get it in that little bit of time that it was out there.
I think something that has to be apparent to developers and other people who are putting things up like this is that it's not that you've got a human being sitting there at a computer trolling through and individually searching. It's that you've got some sort of bot that's doing this at a very fast rate. And I think it's, when you said, why would anybody want to do this? Why would someone go looking for my keys? It's not really someone so much as something.
Right.
I think developers may have a better idea of the ability of software to automate these kind of menial tasks and turn them profitable very quickly. But sometimes you have to make that clear that it's not, you've got one malicious person and maybe 100 instances of a bot that are doing his bidding.
Right. And it's not that they're interested in your key,
right?
Or the bad guy's not interested in your specific key or the code that you have. He's interested in anybody. Mm-hmm. So you're just getting swept up in the activity that he's doing, just trying to find anybody who's posted something that they weren't careful enough to keep secret. Yep. So.
Yeah, just like the argument, why would anybody care about, my PC? Well, they don't really care about your PC, except that it's got some compute power that they can use to aggregate into whatever they're already running. So yeah, it's not so much about you as there's a resource there they can exploit.
Right, exactly. All right, so let's jump into the internet weather. And we actually have some interesting trends in the internet weather that we hadn't seen before. So the first chart we have here is the most probe ports. This is the most raw scan probe activity. So not necessarily a lot of machines doing scanning, but it could be a small number of machines doing lots of scanning. So it's the most probe ports report here. And in this one, this week, and again, this is looking at this week versus last week. We did have a couple of weeks off, so we might have missed a couple of trends that are occurring, and actually we'll probably see some of that here. Some things that we missed or happened while we were all away on vacation over the holidays here. In general here, the top port 135 TCP, we've seen a lot of activity on that for a while now. I didn't bring a chart up on that one. Some of the other ones were a little more interesting. Still not quite sure what's going on there. We know that there's some actors scanning on that and perhaps trying to leverage open file shares or something with NetBIOS or SMB, I guess it is. But in any event, no big new change in that one. Last week it was number one position, same thing. 23 TCP Telnet, we're seeing a lot of scanning on that. There's a lot of embedded devices being scanned for that, as well as the embedded devices scanning in turn for additional devices. If you have a home DSL router or some type of residential gateway that's at the perimeter of your home network, you might want to take a look at it or poke it from outside if you can determine what your external IP address, your internet-facing IP address is, just to see if it's open for Telnet. There are a lot of families of devices out there, not so much in the US, but internationally, there's a lot of devices for one reason or another that are open on 23 TCP, and then people are finding them and trying to brute force password guess their way into these devices, and then turn them into bots. We've seen a few different botnets spin up on these embedded devices. Light Hydra is one of the toolkits. There's another one that's really big right now, and I can't remember what family it is again. But in any event, they're mostly being used for DDoS activity. Some of them actually are doing Bitcoin mining, even though it's a very low-powered device, your home router. But we're probably digressing a little bit too much. 9064 TCP, we've talked about this one before. This is proxy scanning. Whatever reason, I haven't determined why this is. There are a lot of proxies listening on port 9064 TCP. So people are scanning, looking for them, and that's probably just so they can anonymize their activity and use that as a proxy to keep hidden. 22 TCP is SSH. Same reason as the 23 TCP, probably looking to see if anybody has that open and try to brute force password guess their way into those devices. 8080 TCP is HTTP usually. I always mention Tomcat runs on that. We know that there's a few actors out there specifically looking for Tomcat on 8080 because that's the default admin port for Tomcat. But there are some other types of web services that run on 8080 as well that they might be seeking out. 1900 UDP, this is an interesting one. This is SSDP, the Simple Service Discovery Protocol. We've talked about this one before on previous programs. It's had a pretty large jump, up 9 positions from before. And the intent here is probably distributed denial of service attacks, reflection attacks using these devices. And we'll take a look at a chart on that in a few minutes. 10,000 TCP, this is a little oddball one that Matt and I were kind of looking at just before we started taping the show today. This one is up 34 positions. That's pretty significant. And the chart is also pretty interesting on this one. So we're going to take a closer look at that one as well. 445 TCP, that's your SMB configure type things and there's a lot of infections out there still seeking that one out and scanning for that. 80 TCP is your normal web traffic. That could be for a variety of reasons. And then the ICMP stuff, echo requests, are just whatever. It's probably just normal business traffic. So the 9064 TCP, this is the proxy scanning. It's mostly coming from China. You can see I did a pretty long chart on this one, 120 days I'm showing. And you can see way back in July, even early August, there was no activity whatsoever on this port. And it has gone up. We had I wanted to show this long trend because probably we've talked about it, and the last time we really looked at it was maybe early, mid-December in this cutoff point here. And since then, it has resurged at the end of the year here, and it's even more scanning than we ever saw before by maybe a 30% margin or so. So the activity is still increasing here, something to watch out for. I don't know, I wouldn't expect most people to have something listening on port 9064 TCP. I believe that this is mostly devices that are acting as proxy servers. I suspect, although I'm not positive, some of these devices that are acting as proxies on this port might be compromised devices that have been in turn turned into proxies. But I don't have any confirmation of that. That's a little speculative. But one to keep an eye on. If you see a lot of scanning activity on that, you probably have an infected device in your network or something. You might want to take a look at who's originating that source traffic if it's coming from inside your network going out to other devices. The 1900 SSDP. So, I'm sorry, 1900 UDP. So as with a lot of UDP protocols, if you can send a small packet and get more data than you initially sent in your UDP packet. Now UDP is connectionless again. You don't have that whole handshaking that you have with TCP. So if I can just find devices that are listening on SSDP and send a packet towards them and have them send something back, that would be great. So normally what they do in these types of reflection attacks is they'll scan for devices that are listening on the SSDP port, and believe it or not, there's a fair number of them out there. Not as many as some of these other ones like NTP that we've seen or DNS and whatnot, but there's a decent enough number that if you can get a list of these together, you could spoof the source IP, send it to a list of devices that you know are listening on port 1900 UDP, and then the responses all go back to your intended target. And the amplification factor is not super great. It's not like you can get with some of the NTP monolith stuff that we had early last year, but it's still enough. It's more than, if I send 30 bytes in, I might get 100 bytes back out. So there's some factor of amplification there. And so people are more aggressively scanning for that. You can kind of see that towards the end of December here. There's a little bit more density and height to these scanning activity that's going on here. So most of it's coming from the Netherlands, Germany, and France for whatever reason. Not sure why those countries are scanning more than others, but they are. And that's a good one to keep an eye out for. If you have devices, you might want to take a look in your own network, especially internet facing, to make sure you don't have devices that are answering 1900 UDP or have that open because they can participate in these attacks unwilling or unknowingly to you probably. If somebody finds it, they could use you to bounce packets off towards an intended target.
Now, here's a thought about SSDP. Simple Service Discovery Protocol. Is there a value in perhaps using SSDP that's pointed towards the internet in an effort to try and map internal networks?
I think there might actually have been some studies done on that. I'm trying to remember now. There was a vulnerability discovered in one of these protocols. I can't remember if it was SSDP or not. Maybe you can remember. I don't know if Jim remembers or not either. But there was one kind of talked about maybe a month or a half ago or 2 months ago that discussed some devices that are listing. I don't think it was SSDP though. It was another one that
should have been pointing into the LAN, but instead
and by poking it, you could kind of arbitrarily open ports. It was that NAT PM. That's what it was. It was the NAT PMP one, right. Where people could kind of. It's coming back to me now. Too much time off. But in any event, I don't know if you can with SSDP. It does give you some information back, but I really haven't analyzed it. So it's pretty simple. I should say it's not trivial to do, but to send kind of an SSDP discovery query packet and get a response back. But to me, the response doesn't really mean a whole lot. I've never seen any super meaningful responses come back from devices. I think mostly these guys are using it for the amplification of factor alone. And we actually have some other reports that are not in our reporting here that definitely indicate 1900 UDP being used in reflection attacks. So we have some additional types of reporting we do that show certain victims getting targeted with that. Moving along, scanning on 10,000 TCP. Now this one's interesting. This is assigned as the Network Data Management Protocol in IANA, which I'm not quite sure what that means. I forget what the vendor was that was assigned to that. Long story short, though, you can definitely see there's a pattern here where we had some activity over the past, and actually I'm showing a 30-day chart here. We had some activity through December, but not a super large amount, but obviously there's a little bit of upsweep here. And then right around, I'm going to say January 4th probably, so just a few days ago, it has accelerated greatly. And this kind of waveform that we see here, where it spikes early on and kind of trails off, real indicative of botnet originated traffic. A lot of times what happens is botnet controller will tell bots to start scanning. The bots that have a lot of bandwidth, real aggressive, they finish their scan tasks early, other ones take longer, and you kind of get this kind of sloping waveform because of that. In any event, that's probably what's going on here. Why, though, is the next question. And the only two things I could really find was, well, the first one that Matt, you had found this one, zero-day initiative, and actually there is a CVE out for this as well. I don't think I listed it on the page here, but it's been put into the common vulnerability database. And there's an exploit vector that was announced in December 9th, which kind of correlates with the beginning of this. So I don't know whether this is related or not, but it's one plausible explanation. So BitTorrent web interface has a remote code execution vulnerability. If you send a specially crafted packet to port 10,000, you could potentially get some remote code to execute on those devices running BitTorrent, or at least the BitTorrent web interface. So I'm not quite sure how that's leveraged and whether it's related or not. What I did, the second possibility, is I looked in our sinkhole. Our sinkhole showed that we're getting incoming scanning on port 10,000 for this particular URL that I show you here, /cgi-bin/authlogin.cgi. And that happens to be associated with these QNAP devices, which I think that's kind of like an underlying suite perhaps, that there's a couple of different types of devices under that family, and there's a vulnerability in that's shell shock vulnerability that you can leverage. So it might be that somebody's Why it's on port 10,000, I'm not sure, but I know that there's definitely some actors out there scanning on 10,000 for this shell shock bug. And it's embedded devices again. So we talked about the 23 TCP scanning that's been going on, and these other sorts of things. We know there's a lot of these Internet of Things, embedded devices getting compromised by a shell shock, brute force password guessing on their telnet ports, and any other types of means. So this is a likely plausible. We know there's definitely some activity here. Whether it counts for all of this upsweep of activity, I'm not sure, but another thing to keep an eye on.
Yeah, no, port 10,000 is one of those that, because it's a nice round number, has been used a lot by applications over the years. You know, IANA did assign it to the network data management protocol, but I don't know, like you, I don't know anything about that protocol. I don't know people who actually use it. But, you know, there have been, Webmin was on that, Veritas Backup back in the day was on that and was exploitable. You know, this was a number of years ago, 10 years ago or more. EverQuest has been on there, BitTornado's been on there, and now these QNAP embedded devices have that management interface on there. So that's a port that, because it's a nice round number, people kind of liked it, and so they stuck all kinds of stuff on there.
Okay, well that's good input there.
Point of information, NDMP is apparently used for facilitating backup jobs between NASs, network attached storage devices, without having to involve a backup server. So whereas most users would come through a backup server to reach the NASs, this allows you to do backups from NAS 1 to NAS 2 to NAS 3 and never involve the server in the center. It was apparently, protocol was developed by NetApp and Legato.
Okay.
So.
Back in the day, okay.
But it sounds like from Jim's list that this is one of many, many possibilities. So for what that's worth.
Right. Okay. Well, maybe we'll find out a little bit more information in the future. Obviously, it appears to be that there's a lot of aggressive scanning going on from our previous chart here within the past few days. Looks like a botnet's initiating that scanning. Haven't tried to do any analysis to figure out what botnet that might be, but another one to keep an eye out for, as well as look for any activity that you might see on port 10,000 TCP, because it's probably not traffic you want. Next chart here is the most sources probing. This tends to be a little bit better because this kind of shows when there's coordinated activity between botnets and things like that, where you've got a lot of sources doing coordinated scanning activity all at once. Not a whole lot of difference, no real big standouts from before. This one also doesn't change as much, the positions, because you need to get a lot of individual devices doing something in unison together.
Although what does stand out from this chart is the size of the slice for 23 TCP.
Right, good point. 23 TCP accounts for, well, I'm just eyeballing, but I'm going to say probably 40% or so, roughly, of the entire pie, even including the other stuff. So this is based on a large population of ports that could be scanned. So 23 TCP is really taking up a lot of the coordinated scanning activity. And again, like we talked about, a lot of embedded devices out there. These DSL modems, residential gateways, your
DVRs.
Security camera DVRs. We talk about this all the time if you watch the show. And you want to make sure that if they're internet facing, that you've got those locked down. If you're not sure how to check, I don't really have good recommendations other than do some of your own port scanning against those from the internet, from a remote host, not from within your network, but try to poke your own devices to make sure that they're not listening on ports that you're not expecting them to be listening on, and especially 23 TCP. But even still, any of these other ports that we talk about would be good ones to go make sure that your devices are not listening on, because they might be exploited if they are. Or at the very least, they'll get brute force. If you have Telnet and SSH open, there'll probably be actors out there trying to brute force password guess. If you're using SSH, you actually have a little bit better chance, especially if you use public-private key type, use a key as a method to only permit access to your SSH via that instead of password-based. But in any event, additionally on the list here, 27015 UDP. No big surprise there. That's the gaming for the Valve Steam protocol. 445 TCP SMB, we talked about that one already. 6881 UDP, that's BitTorrent probably. It's a little bit increase in BitTorrent. Actually, it's gone down a notch from the previous week. I kind of wonder if there's a lot more BitTorrent over the holidays because people are home, they're on break, maybe even some movies that have been released in the movies that shouldn't have been released that did get released, such as the one from Sony, might have increased a lot of BitTorrent activity. It's a little speculative, but a little bit of more BitTorrent than we had normally seen before, especially coming up in this list in the scan activity. I don't think we normally see BitTorrent in the top 10. 1900 UDP went up 8 positions, and we already talked about that. That's the SSDP again, probably related to botnets engaged in the scanning activity for finding devices that are vulnerable to that, so they can use them in DDoS attacks. And then the last one was this 3159 UDP is up 1 position. This is an interesting chart as well. Now this is one where I don't think we've ever talked about this port. I don't know anything about this port. And this is a really interesting chart though, because this kind of shows us what happened while we were away. If you go back to prior to 1218 or 1217, it looks like about here, there was basically no scanning activity on this port, 3159 UDP. Incidentally, this is assigned in IANA to Naviga Web Terrification, which I know nothing about that protocol either. What I am able to tell you is that we're seeing a lot of scanning activity here. It's gone from basically nothing up to a significant volume here. And it's mostly from the US, mostly from US sources. Part of that makes me think that maybe this is somewhat legitimate activity. I wonder if it's some new peer-to-peer thing that I don't know about. So if anybody out there actually has information on it, I would be more than happy to please contact us and let us know what you know so that we can relay that information to everybody who watches the show. But I'm not quite sure. I don't know if you found any other information either.
No, I think I found the name Navega Web on a Portuguese website. They seem to be either some sort of ISP or somehow involved with the internet space. Tarification, it may have been, this may be a mistranslation, but I think it had something to do with pricing or billing. So maybe there's a custom protocol here that was once used by this company or still is used by this company, but these are guesses.
Yeah. And in terms of...
I also saw on one of the sites where I look for information on ports that it was in the range of ports that was used by the Rainbow Six Vegas game. Now, that was several years ago, so I'm wondering if there was another video game of some sort that was using that port for some of the peer-to-peer stuff, because that was a PlayStation and Xbox game from a few years ago, 6-7 years ago, I think.
Yeah,
so,
I guess.
And just the timing of that, on that chart makes me think it did start a little before Christmas, but that kind of looks like a video game. Lots of students off school. Let's hit that pretty hard.
Right, it's possible. I guess the one thing that confuses me about it is typically with gaming, I guess it depends on how the gaming is set up. It wouldn't show up as scanning normally because it's usually directed. Like my gaming client's gonna connect to a pool of servers maybe and do that activity. Whereas this looks like scanning that's widespread across the internet. And they're looking all over the place for anything devices that are basically from 0.0.0.0 all the way up to whatever, 255, even though that's not really what they're doing. So that kind of has me a little confused, which makes me think it's more of something really peer-to-peer related, where you got a lot of devices all wanting to talk to each other for some reason. And I don't know. I guess maybe we'll find out more information as time goes on here, hopefully. It is kind of new, but it's one of those things that we had not seen prior to us kind of going away on break here. And now that we come back, there's definitely an increase in activity here that we should take note of and try to figure out more about what's going on here.
Yep, this is one I'm definitely going to look for on my home network and see if I can capture some packets.
Right, that's another good example. Yeah, good idea. If you can get some, like a sinkhole or a honeypot going and grab some packets of incoming traffic, scans for it. Okay. So that's our show for today. Thank you for joining us. If you'd like to get in touch with us, you can email us at threattrack@list.att.com. You can also find the ThreatTraq program on the AT&T Tech channel. It's at att.com/ThreatTraq, and that ThreatTraq is with a Q at the end, TRAQ. It's also available on YouTube and iTunes. You can also follow us on Twitter. Our handle on Twitter is @ATTSecurity. Thanks, Jim. Thanks, Matt. I'm John Hogoboom. We'll be back next week with a new episode. Until then, keep your network safe.